you only use 10% of your brain. The line lands with a thud of certainty and a promise of hidden power. Tonight we test it. We'll trace where the number came from, what modern neuroscience actually measures, and why idle does not mean unused. It matters now because brain hype sells. From nootropic ads to clickbait quizzes, the myth fuels products and shortcuts that promise an easy unlock instead of steady learning. The idea likely started as a mix of misquotes and misunderstandings. In the 1890s, William James wrote that we rarely tap our full mental resources. Later retellings squeezed that thought into a neat percent. In the 1920s and 1930s, Carl Lashley removed chunks of rat cortex looking for a memory engram. He failed to find a single spot, which some readers oversimplified as much of the cortex is spare. Early brain imaging in the 1980s and 1990s added a bright new confusion. PT and later fMRI highlight areas with increased activity during a task, and people took the dimmer areas to mean off, not baseline. Self-help books and pop culture did the rest. 10% sounds tidy, empowering, and conveniently fuzzy, which made it perfect for posters and movie plots. Now the evidence, piece by piece. Start with injuries and strokes, because damage reveals what matters. If 90% were useless, large injuries would often do nothing. Instead, small lesions in Broca's area derail speech. Tiny hits to the hippocampus shatter new memories. Narrow strokes in the occipital lobe erase slices of vision. Across clinics and decades, the pattern repeats. Specific damage causes specific deficits, which means the tissue was doing something necessary before it was lost. Next, energy. The adult brain burns about a fifth of the body's resting energy, even when you sit quietly and daydream. Evolution does not carry metabolic deadweight for fun. A system that hogs fuel at rest is almost certainly active, even when no one asks you to solve math or juggle words. Consider what activity means in a scanner. fMRI does not read thoughts. It tracks blood oxygen levels as an indirect sign of neural work compared to a baseline period. A region that does not light up in a contrast image is not asleep. It may already be humming at baseline or handling background tasks that the experiment did not label. Over minutes and hours, tasks recruit different circuits: reading, walking, musical rhythm, spatial memory, emotion, balance. Each nudges a distinct but overlapping set of regions. Add those sets across a day and you touch almost everything. Not all at once and not with equal intensity, but far more than a sliver. Idle is not unused. Idle means ready. Now the architecture. The brain works through distributed networks, which are sets of regions that coordinate to handle a function. A rest state network is a group of regions that naturally synchronize together when you are not doing a specific task. The best known one, the default mode network, links midline and temporal areas that support memory, imagination, and self-reflection. Those networks fire even when you stare at a wall. Your brain shuffles past and future, consolidates learning, and simulates alternatives while you do nothing. If you add attention and control networks, the frontoparietal systems that guide focus, you get a seesaw. When one lifts, the other often dips, which keeps the whole machine stable instead of spiking everywhere. That seesaw fools people into thinking the dipped side is off. It isn't. It's throttled to keep noise down while another circuit takes the lead. Electrical stimulation tells a complementary story. Surgeons mapping cortex before removing a tumor can disrupt speech, movement, sensation, or vision with tiny currents in tiny spots. Those maps shift between people, but they rarely find vast deserts of irrelevance. Instead, they reveal a crowded city with specialized neighborhoods and lots of cross streets. Training changes those streets. Violinists show enlarged sensory maps for the fingers of the left hand. Blind readers of Braille recruit visual cortex for touch. Bilinguals manage control loads differently across language networks. That's plasticity. Plasticity means the brain can rewire through experience within constraints of anatomy and energy. Constraints matter because the brain must avoid runaway activity. It runs at comfortable margins and uses inhibitory neurons to keep signals tidy. Seizures demonstrate why using more is not magic. A seizure is massive, synchronized activity, and it disables function rather than supercharging it. Sleep seals the lesson. During deep sleep, the brain's rhythms consolidate memory traces and clear metabolic byproducts. During REM, it rehearses sensor-motor patterns. Rest isn't wasted time. Rest is maintenance and integration, which are forms of use. What about the strongest alternative explanation? That the myth is metaphorically true because we rarely push our abilities. There's truth in that sentiment, but it confuses effort with tissue. We often fail to train skills to our personal limits, which is a motivation problem. That shortfall does not imply 90% of neurons quietly wait for a switch. Correlation and causation must part here. Correlating quiet scanner images with the claim of unused brain causes the wrong conclusion. The cause of quiet images is task contrast and inhibitory balance, not non-existent function. Across decades, replications line up. Lesion studies, stimulation maps, metabolic measures, and network imaging all converge on a brain that is busy, distributed, and constrained, not a warehouse with 90% empty. There are genuine unknowns. Scientists still debate the extent of adult neurogenesis outside the hippocampus, the fine-grained roles of subcortical hubs, and how individual wiring differences shape learning. As of recent studies, we keep refining how rest state networks interact with task networks and how sleep stitches the day as fragments together. The details move, the big picture holds. So why does the myth feel so good? It offers hope without friction and makes every failure look like a locked door, not a staircase. And it offers a hero story. If a guru or gadget can unlock the missing 90%, you get a shortcut to genius. Here's the practical rule of thumb. When you hear a claim that we use only X% of the brain, test it on 3 questions. What measurement supports that number, compared to what baseline, and by what mechanism would increasing the percentage help rather than harm? If the answer leans on old quotes, vague scans, or cinematic intuition, pass. Prefer explanations where injuries, stimulation, metabolism, and behavior all agree. For learning, trade fantasy for physics. Pick skills you value, practice them just beyond comfort, sleep enough to consolidate, and protect your attention so networks can rewire. Expect limits because energy, anatomy, and time bind us. Embrace plasticity because effort within those limits grows real capacity. In short, we already use all of our brain across time, and the 10% story mistakes momentary peaks for true potential. Your brain is not missing, it is managing. Subscribe for more myth versus reality, and tell us which stubborn claim you want examined next.